Okay, so we got two balls thrown upward from the edge of a cliff. So basically what's happening is two balls being thrown up from a cliff. First one is thrown at 48 feet per second, and then another one is thrown at 24 feet per second. The picture isn't necessary. It's just there to show you what's going on. The first is thrown with the speed of 48 feet per second. The other is at 24 feet per second. Do the balls ever pass each other? So basically, the question is, let me rephrase that. When we do each one, we're eventually going to get some distance function, s1 of t, s2 of t. s1 of t, the distance function that goes with this ball, and then we'll have the distance function that goes with this one. All right, everyone following so far? So we have two distance functions. What we want is, when does s1 of t equal s2 of t? Okay, so we're going to have to find the distance functions for each one. Yeah. By the way, there's me talking, if that helps. Okay, so the first one, which was 48 feet per second, that one actually comes from example 7. So for the 48 feet per second ball, we know from, where's example 7? There it is. We know that the distance function is negative 16t squared plus 48t plus 432. So this was the distance function given to us from example 7. What we have to do is use the same method that example 7 used to find that function to find s2 of s2. Alright, so I'm going to delete this, and then we'll start with finding the distance function for the second ball. Now, the way example 7 works is we would start with a of t to equal negative 32. It stands for negative 32 feet per second squared, because that would be the acceleration. All right, and then to find velocity, we would then take the antiderivative of negative 32, which is negative 32t, plus c. Okay. We have, now here, this is actually the tricky part, is the initial conditions. So let me write this down. Initial conditions. Let me read the initial conditions again. It actually says the first one is thrown, and then the other one is thrown a second later. So what you would think is you would say, okay, the initial velocity is 24, which isn't true. Let me just double check that. Yeah, which isn't actually true, because we're doing this 1 second into the toss. You know, we throw the first ball up, so the second ball is thrown a second later. So the actual initial condition is v of 1 equals 24. Okay. So that's important, because if you get that part wrong, then the rest of the problem won't work. Okay. All right, so we have the initial condition. We also have s of 1. Now, when you're standing on that cliff and you're about to throw, you throw the 48 feet per second ball, and then you wait a second, and then you throw the second ball. That initial condition, right before you throw the second ball, it's at a height of 432. So this is the initial height, and this is the initial velocity. All right, so we're going to use these initial conditions to find this c here, and then when we find s of t. Okay, so then use this initial condition here. So v of 1 is going to equal negative 32 times 1 plus c equals 24. And then you would solve for c. Okay. So c is 56. So v of t is going to be negative 32 t plus 56. Okay. Now we're going to use v of t to find s of t. So any questions before I delete this? Are we all okay? I just need one person to say okay. Okay. Good. Thank you. Unique name. All right. That's a neat name. Okay. All right. So now what we're going to do is we're going to find s of t. Now, if v of t is negative 32t plus 56, then s of t is the antiderivative. So we're going to get negative 32t squared over 2 plus 56t plus c. Alright, so, and then let me simplify that as negative 16t squared 56t plus c. So that's just the basic antiderivative. So nothing tricky there. But now we're going to use the initial condition we have. Let me write that down. The initial condition was that s of 1 is 432. Again, not s of 0. And that was pretty much the hardest part of this question was it's not s of 0, it's s of 1 because that second ball is thrown 1 second into the toss. Okay, so let's plug in s of 1. So s of 1 is going to be negative 16 1 squared plus 56 times 1 plus c, okay, equals 432. Alright, and then when you solve for c, which I could probably leave that, there we go. I'll leave that up to you, but when you solve for c, you should get, what does my calculator say? 392. Okay. So s of t is going to be negative 16t squared 56t plus 392. Okay. All right. How are we on the second distance function? We okay? Any questions? Good. Thank you. Okay, great. All right. Now that we have the height function, again, this is actually the height function. We have the height function for the first ball. We have now the height function for the second ball. So what we're going to do is, if you want to find out where the balls pass each other, you're looking to see when do the heights equal each other. All right. So for the 48 feet per second ball, what was the sorry. Its height function, which now I forget. Okay, it was negative 16t squared plus 48t plus 432. And the 24 feet per second ball that height function is negative 16t squared plus 56t plus 392. So if the balls are going to pass each other, the heights have to equal each other. So what we want is we want to solve S1 of t equals S2 of t. There's actually another option. You can watch it like this. This one's actually, it's probably a lot more laggy. So let me see. How's that? Is that view? See how the camera's really close? So I will probably not stay on this view, but that's one of the views here. Okay. Okay, so we're going to set the two functions equal each other, and then we'll solve for t. So we get negative 16t squared plus 48t plus 432. That equals negative 16t squared plus 56t, 392. The negative 16t squareds are going to cancel. I'm going to bring the 48t over, so subtract 48t. And then I'm going to subtract 392. I'm going to bring that over. Okay. Alright. So when you subtract these two, you're going to get 40 equals, what was that, 8t. So when you solve, you'll get t equals 5. What we basically just did was we found out how long it would take for their heights to be the same. In other words, how long it would take for them to pass each other. Now the question, let's get the book. The question was, do the balls ever pass each other? The answer is yes, they pass each other after 5 seconds. And that is the answer to